So this is basic food chemistry. We're going to talk about chapter 3, which is colloids. So you might be wondering what the heck is a colloid. So a colloid is a dispersed state of matter. And when you're looking at these things, the size of particles that are dispersed make either a solution or a colloid. So a true solution will contain particles of less than 1 nm, which is a nanometer in size. A colloid is a little bit bigger than that. They are 1 to 100 nanometers, so a little bit bigger particle size as compared to something that's completely mixed within each other because of small particle size, which would be a solution. Okay. So we have two types of colloids overall. There is the lyophilic, which is pretty easy to form. So when you make like a gelatin, it's like jello, glues, stuff like that. And then you have the lyophobic ones, which has a very little affinity for dispersing, and an example of that would be gold. So for the intents of foods that we're talking about in food chemistry in the colloids, we're looking at three different types of dispersions. So we're looking for something that's solid within a liquid, or you're going to have a liquid within a liquid, which is called an emulsion. And then if we're trapping or dispersing gas within a liquid, that is a foam. Okay. And so it comes in two distinct phases. We have the actual dispersion medium and the dispersed phase. So let's talk about an emulsion. A lot of people don't realize what actually emulsions are. An emulsion is a colloidal system made up of two mutually insoluble liquids, one which is dispersed as droplets in the other. So a lot of people don't know mayonnaise is an emulsion, okay? Miracle Whip, those kind of things, those types of salad dressings basically have a fat and a water base to it, and they are mixed together. Even though they're typically not soluble together through necessary means, whether it's a binary agent or through friction or force, we can actually make them bind together. Most of these are usually unstable, so you usually have an emulsifying agent that actually holds them together. So that keeps the droplets apart so they don't go through what they call coalesce into a continuous liquid. They stay basically phased together. So you can see in the liquid basically the water and the oil that are mixed together into the water phase itself, and it's about those little droplets in the middle, those red particles that you can see. Those are what is actually holding that colloid together. Another thing is soap. Soap is an emulsion, but obviously, is it used in foods? Well, for cleaning and that kind of stuff, sure, but as a food, no, not really. So in foods, it's usually gums and proteins that we use as part of this interface, and so we can have mixtures of several different compounds together rather than just one. So really, the type of emulsion that you have is going to be affected by the ratio of the two phases. So an example is when water and oil you think are shaken together, both the water and oil and water emulsion will result. So sometimes you have oil dispersed with water, sometimes you have water dispersed with oil. So think about some types of salad dressings where you have to shake them up and eventually they do separate. Okay, so they form when you actually go through that motion, but eventually they're not suspended in each other enough that they're going to stay that way. So if the amount of water is much larger than the amount of oil, the oil water becomes more stable of the two. Okay. So again, it's all about how much you're actually adding within this emulsion to make sure you can form the proper emulsions and allow it to not break. So with an emulsion, temperature becomes one of the biggest aspects of it. So you can read here that when you have a higher temperature, that actually decreases surface tension and viscosity within that interface, and so the emulsification is more easy. The problem that this poses in foods is now you're raising temperature, but having an immersion and making it cold is sometimes quite difficult. So again, the biggest thing is making a food emulsion is pretty complex. And most people don't even realize this also, but your true hot dogs that you go and purchase are emulsions. They're basically made from a meat batter, so we've got some fat and protein in there, and then we've got some water. Now, the water will interface with the protein quite well, but with the fat, no. But how we get them to form an emulsion within that batter is we add basically bit in a high-speed chopper, and it's the friction and creating a little bit of heat that is actually going to suspend those two within each other. So as mentioned previously, emulsions can break, and it's usually sometimes it's a physical cause that actually is the culprit, and sometimes it's a chemical thing. So when the chemical uh, causes the emulsion to break, it's usually from altering the pH, and then altering or destruction of the emulsifier become important for this to happen. And sometimes you do want the emulsion to break, but most times you don't. Physical, it could be from too much agitation, so churning or stirring. It could be filtration. If you centrifuge, things will separate out, again, because of different masses or molecular weights. Freezing, heating, the addition of liquid, or the addition of two solids, all those could cause an emulsion to actually break down and not hold its form. As mentioned, another form is a foam. So this is a colloidal dispersion of gases in very viscous liquids. So it's got to have some density to it. So making a foam with water, not really going to happen. It's got to have some viscosity to it. So there's actually becomes an interface between the liquid and the gas. So if you think about whipped cream, that is a long-lasting foam. So I think about the cream that's used to make it. It is a pretty viscous liquid compared to like regular milk or some other types of water products. Marshmallows and meringues, they're foams, but they're stable because the protein that's present, usually a gelatin for marshmallows, and if you have egg albumin, so the egg white that's in a meringue, the protein there allows for stability of that foam. Think about when you pour a glass of beer or have it and you have foam, what they call the head on it. That actually is pretty stable because of basically gum and dextrins that are extracted from hops used in the brewing process. They actually concentrate at the surface film and then yield the foam and release the carbon dioxide. So, but a pure liquid will not form a foam, so definitely something to know. So talking about viscosity a little bit, so understanding what that is, it's basically resistance of flow because of internal friction. So you think about thickness of weight of certain motor oils. You think about that, so the thicker they are, the more viscosity they have to them. And of course, over time, those motor oils break down and become more thin and become less viscous. So again, thinking about our liquids here, the more viscous they are, the more resistance, the thicker they are, as opposed to being very thin and watery. So the last one gets you a little picture here of an emulsion. So depends on of course, using the ingredients, the amount, type, and quality are definitely going to have a big impact on it. And then you got number two, the pH is definitely going to have a large impact on the stability of that emulsion. Also the surface charge, again, as it has positive ions or negative ions, in this case positive, and they're the Fe, which is iron. Of course, viscosity we talked about is number four. Number five, the oil droplet size or surface area, again, making sure there's enough surface that they get coated and be able to be suspended. Processing conditions that would come in, like again, temperature has got to be a big thing, and how much additional heat is created with friction. And also, we can use antioxidants to help in that stability. So, again, understanding that you've got water and then we've got oil, and we're trying to immerse them together. All right, that's just a little bit of a background of a colloidal solution chapter. So, complete your quiz in Canvas and move on to your next one.